There are a few more reactions revolving around alcohol groups that we're going to talk about, or the hydroxyl group making an alcohol. One of them is called dehydration. If you think about that a little bit, what is happening to you if you are dehydrated means that you don't have enough water and you need more water. So same sort of things going on here. We have an alcohol forming an alkene because it's lost water. And it requires heat, sulfuric acid, and or phosphoric acid to help with some oxidation. And the secondary product is water. We can think about the reverse reaction here. The industrial production of alcohol generally involves a hydrolysis reaction, the opposite of a dehydration reaction. We're adding water to it, which means it's an addition reaction. And that requires steam, so water or heat, that heat again, but with lots of water, phosphoric acid, and a catalyst of aluminum oxide. And it also requires high pressure. So this is a not very safe and pretty expensive reaction to occur. So let's take a look at both of these. Starting out with the dehydration. So if we have, let's just have ethanol. That's a nice easy one for us to have. So eth meaning 2 carbons, all meaning an OH, a hydroxyl group, and hydrogens filling out the rest of the spots on the carbons. So what happens here is the reaction's hydroxyl group on the first carbon and the carbon that's right next to it, one of its hydrogens, are going to be removed. And this is where that one product of H2O is formed. And this produces an intermediary. So initially, before we get too far into the reaction, we have a carbon that has 2 hydrogens on it and a radical, and it's bonded to a carbon with 2 hydrogens on it and another radical. So assuming that there's not a whole bunch more of these alkane radicals around, what we end up getting is those 2 radical bits here and here end up satisfying their total bonds by going and forming a double bond. So this is that alcohol to alkene dehydration. And then the opposite direction, what we do, and we saw this already when we were looking at addition reactions, but we're talking specifically about addition with water. And so we're going to call it also hydrolysis. Gotta love multiple names for things. And so again, let's just look at the ethene that we just finished with. If we're looking at the reverse reaction. So ethene, C2H4 plus water. Okay. So initially, this double bond breaks, so we get an intermediary of CH radical radical H H H and H. So there's one intermediary, and then we can think of the hydrogen being bonded to a hydroxyl group. It's the same thing as H2O there. And what happens is when that bond breaks apart, that radical gets a hydrogen and that radical gets a hydroxyl group, and we form our ethanol, C, C, H, 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 and OH.